Paint or Smart Vector workflow is one of the newest and most powerful additions to Nuke, and it's a way of ensuring that fixes or decals applied to one frame apply perfectly, warping into place across the rest of the sequence. So let's take a quick look at our example shot here. I'm just going to stop this and move back to the start. So as you can see, the sequence features an actor in front of a car answering a mobile phone, and he's got a couple of different bloodstains on his shirt there. Now this bloodstain here in the middle is actually applied entirely using the Smart Vector workflow. It's placed on frame 1, and then the Smart Vectors are used to ensure it perfectly matches the movement of the shirt across the rest of the sequence. And if I just toggle my merge on and off, you can see the before and after of that bloodstain. Now there are two tool sets that I want to cover briefly here. The first one allows you to warp a fix or decal into place across the course of the sequence, whilst the second one allows you to warp a mask, which can then be used for grading or color correction. So let's just jump in and take a quick look at this left one first. So let's start by taking a look at the inputs for my tool set. On the left hand side we have the plate input, so just my background movie. And on the right hand side we have the target, the thing that I actually want to warp into place over the course of the sequence. So in my case that's the bloodstain on the actor's shirt. Now importantly, I've ensured that this bloodstain matches up exactly where I want it to be on the shirt at the first frame of the sequence. And this first frame is going to become my reference frame for the vector distort later on in the process. Now using SmartVectors in Nuke will always follow roughly the same workflow. You start by rendering out a sequence of smart vector images to disk, which is essentially Nuke calculating the pixel movement across the course of the entire shot. You then use the vector distort node to use that sequence to distort your target so it matches perfectly on every other frame. So let's just zoom in a little bit here and we'll take a look at the nodes involved. First of all, for rendering the smart vectors, we use a smart vector node. And if I bring that up, you can see that its properties are pretty simple. We have a file path describing where the sequence that will be rendered needs to live. We have the range, which explains which frames we're actually going to calculate smart vectors for. And finally, we have this vector detail setting. Now, the higher that setting is, at this point I've got it at 0.95, which is pretty high, the better the quality will be. However, it will take longer to render if you've got that value set higher. So it's just worth taking that into account. Now once you've rendered this out, you can actually then use it using a vector distort node. And this node has two inputs. At the top we have our smart vectors coming in, and on the right hand side we have our source, which is our target bloodstain image that we wish to warp into place. If I take a quick look at this vector distort, you can see we only see that bloodstain. Of course, we're not seeing our background at the moment, but if I then start playing back, you can see that this will slowly warp across the course of the shot. So let's just stop that there, and I'm going to quickly move over into the compositing section of our toolset. Now obviously at this point we've got this perfectly warping to every frame, but it would be nice to see it with reference to the background plate as well. So I'm just going to come down to my merge and hit 1 on that to view it. Now there is a grade fix decal section here as well, so if you do need to grade this in additional ways to ensure that it matches across the course of the sequence, you can do that. But at this point we're pretty much done with our vector distort. You can see that it is matching perfectly now on every single frame. And I think it would be really quite hard to pick that this was done using an automated process inside of Nuke. So that is the first tool set. Let's take a quick look at that second one. Well, the previous toolset was used to move a fix or decal into place over the course of the sequence. This one is being used to warp a black and white mask. And so our bloodstain at the top here has been converted to just that, a black and white alpha mask, which can be used to grade the plate later on in the process. Other than that, we're still doing a lot of the same things. We're rendering our smart vectors to disk using a smart vector node. We're using a vector distort node to distort this bloodstain into place over the course of the sequence. Now it is worth noting that inside of the vector distort properties we have this reference frame value. Earlier I mentioned that I'd set this up so that my bloodstain perfectly matched exactly where I wanted it to be on frame 75, the first frame of my sequence. And so that's why my reference frame is set to frame 75. Nuke will do no warping of that input image on its reference frame, and every other frame will have its transform calculated relative to this value. So let's just close that down, and then I'm going to come and have a look at the bottom part of this toolset. Now on this left hand side we have our plate coming in, and I'm using our transformed mask as a mask on a color correct node, and then also on a grade node in order to color correct our plate. Now of course, because I'm using the smart vector workflow, that mask will now transform perfectly over the course of the entire sequence. There is one final SmartVector toolset I want to quickly cover with you, and this can be a nice quick way of ensuring that your Nuke scripts continue to run as quickly as possible if you're using the same SmartVector sequence to warp multiple things into place. So in this case, I've got this single shot, again the same shot as before. We've got the bloodstain on the shirt here, but I've also added a bloodstain just on the corner of the head, which is again being tracked across the course of the entire sequence. Now, although this is still really quick on my system, you might find instances where Nuke starts to slightly slow down if you're using multiple instances of that vector distort node. So let's just take a quick look and see how this last toolset can help us out. I'm just going to select it and zoom in slightly. Now you can see at the top here we only have a single input, our plate, and that's because we're not using this toolset to do any of the actual warping. We're just generating another file format that Nuke can read a little bit more easily than that SmartVector EXR sequence. So let's just go top to bottom. First of all, we're going to render our SmartVectors exactly the same as before. Then in the middle here, we're generating an original ST map. So let's just take a quick look at that expression node and see what it looks like. Now, although it doesn't look like too much at this point, an ST map is another way that Nuke can use to warp our bloodstains into place. However, before we do that, we actually need to warp this ST map to match the motion of the shot, and that is where we're going to use our vector distort node in this toolset. So let's just take a quick look at the result of that. Now what we'll see is that over time those gradients will shift into these kind of slightly swirly undulating patterns, and you might even be able to pick out our main character here on this right hand side. The key thing is that this is now a format that Nuke can use to do that warping for us. So finally we write out that full STMap sequence to disk so it can be used elsewhere in our script. Now that we have this STMap sequence written out, we can start using it by bringing in, first of all, a read node pointing to the sequence itself, and then an STMap node. And as long as we point this STMap node to the R, G, and B channels of our newly rendered sequence, this bloodstain is going to warp in exactly the same way as before. And just as a quick example here, I have the STMap on the left versus the vector displace method on the right, both being used to warp two bloodstains into place. As you can see, the STMap is already finished in about a third of the time it takes for the vector displace node to complete the same task, just showing that if you know how to optimize your Nuke scenes, you can get things done an awful lot more quickly. So that's a quick look at the SmartVector toolsets now included inside of Nuke.